All right. Now let's look at one example. Huh? So example number 10, you read the statement. When the skitter reached point A along the parabolic path, he has a speed of so and so, increase at so and so, determine the direction of his velocity and direction, and magnitude of his acceleration at that instant. Ignore the size of the skitter in the calculation. Mean you ignore the projectile question, right? Now this question, this statement also give you some hints not to involve projectile question, which is the involve gravity question, right? Now, of course, this question can, if this statement is, this question can extend into projectile question with a separate section. Okay. All right. If you're having the tutorial handout, you'll see the photo right away. But I'll give you some info first. So in the photo, in your tutorial handout, you will see two axes there, X and Y, and this is a hill, right? So skitter, you will skid from somewhere, and then you will land on this path. Okay, so the skitter will be from somewhere, and then you follow the parabolic path, and then it landed here, and continue to follow the path of the mountain. Right? So the skid is landed at that point, and at that point of A, this skitter had a speed of 6 meters per second, and is continue to increase in accelerate 6 meters over second square. Okay, and you're given a curvature of the curve equation y equal to something x squared. Y equal to 1 over 20 x squared. So you're given the equation. All right. And then there's a height at that particular point A. So point A, if you measure from reference, the y position is 5. And x position from the ending point in the origin there will be 10 meters per second. 10 meters. So basically, point A and point A, you can plot, you can see as a Cartesian plane where you have x location and y location. Okay. Now, recall back what are the steps that we mentioned in the first session. First, sketch the coordinate system. Know where is your origin. Know where is the axis. All right. You need to plot your normal and tangent axis. Put inside the velocity. Put inside the information, for example, acceleration. All right. So you put in the, this is a curve, right? Curve. Where is the normal axis is always pointing to the center of the curve. So normal is pointing there and not over here. Right? So just follow the curve. Another one, tangent, is direction of your skitter. And it's not over here. Of course, you want to, of course, you can put tangent over this side, no problem. But if you put your t over this side, or your calculation, you need to be careful on the positive and negative sign later on. So to have a convenience in our calculation, I put my tangent positive is pointing towards the direction of my skitter. Okay, so there are some different from the previous lecture content. I flip the direction of my t from the conventional direction, which is this direction. So I flip my t, positive t, towards the direction of my skitter, so that my calculation, all the direction to that position, to that direction is positive. So I get positive value in the calculation. All right? Okay. Any question on showing the coordinate system from the statement here? Anyone you don't know how to plot the n and t? Okay, yeah. Then I draw the direction of my velocity. I put as v sub a represent my velocity. And if I extend my tangent line, if I extend my tangent line, there is an angle. There's an angle of changes by referencing the horizontal axis. I will have an angle of rotation or change of angle. Right. First, we solve the coordinate system, that what I mentioned just now. Where is your fixed point? Where is the n and t axis? And we will use the n and t to find the v and a component on this axis. Right? Next, we find velocity first. Again, recall what is a okay, velocity is a vector. Vector have magnitude and direction. Velocity direction always tangent to the path. You having this curve, right? Y equal to something x squared is a quadratic equation, or you can say as a curve equation. So you're having a curve like that. You draw the t and n. Let's say this is your point A. Your direction of your velocity is tangent to this curve. VA, this is A, VA equal to 6 meters per second. And there's an angle compared to the horizontal axis. All right. Now, this is what I expect in your answer. You need to know how to sketch this diagram. Okay, you copy the curvature or the curve equation or the curve shape. You can write your equation over here, but what is important is the curve or the path traveled by the skitter or the object. Put in the location of that object, A. From the A, draw your normal axis and tangent axis. And again, in this case, I flip my positive from the traditional one. Traditional one, your T is going this way. But I flip my direction positive to another side to align with my skitter so that all my vector that I use just later will be positive component and not negative. If you draw T over here, this one you need to put in negative sign in front. Okay, so I just give some convenience to myself. I flip the axis to the direction faced by the skitter. Any question on the velocity schematic diagram?
Excuse me, sir. Last part I didn't understand.
Yeah, can you just repeat the last part again, sir?
Which part?
The one where you said you flipped the axis or something. So.
Oh, okay. You understand this axis, right?
Yeah, this is okay.
All right. Now, you start with drawing a path of this one, and then you mark the location of A. And then from location of A, you draw the direction of your normal and tangent axis. So normal axis, how you draw? Your T is going this way, right? If this is your X, this is your Y. So your Y always pointing up, no issue for you. You know also the direction of normal always pointing to the center of curve. So it's this direction. And the relationship between the normal and tangent always 90 degrees. So it can be this side, or it can be going this way, or it can going this way. So normally, if you put this one your t is in this direction, meaning your positive direction is this direction. So when you put your velocity in this way, because your skitter is going down, if your t is, if you label your t over here, it means your velocity go against the direction of your tangent axis. So the value that you use in your calculation is no longer positive, but it go against the direction. If you're using the t over here, your velocity will become negative because it's go against the direction of the t. So in this case, because I don't want to see negative value in my answer, I flip my positive axis to the direction of my skitter. So I flip from the traditional t over here, I flip over here, means that all the value to this direction is positive. So no matter at the end of the answer, if I get positive, it means my object going towards this direction. If I get my answer towards n component later, I get positive, means my object going this direction. So I put my v over here, follow the t direction, and I can use the positive value of my v. Do I explain that? Do you understand
Yes,
now?
sir.
Okay.
Understood.
Yeah. So be careful on the axis that you choose, because it will snowball to your answer later on. Okay, because the axis itself gives you where is positive, where is negative. So in this case, I give a convenience to myself. I flip the direction, and I tell myself that the skitter direction is going down, so I want all my answer in this direction is positive. So I label this direction as T. And there's an angle of positive, this one referring to the level of my ending point to this one. So this one and this one is parallel. Okay, this line and this line is parallel. So that's why I get the angle of changes. Right? So the next one is look at your equation. Y equal to this curve, y equal to 1 over 20 x squared. Why we need to find the dy dx, and even one more second differential, it's because the equation before this slides, we show you that that is an equation to find the radius of the curve. This is where we apply the equation. So from here to here is first order differentiation. So 1 over 20 x squared, you differentiate one time over x, so 2 go in front, 2 minus 1, so 2 over 20, you get 1 over 10, x 2 minus 1, you get 1 over here. So this is the answer for dy dx 1 over 10x. Okay, so this is how we apply the coordinate that I mentioned just now in the first session. You know the coordinate of your A, all right? Your A coordinate is bracket 10, 5 over here. Your x coordinate is 10, your y coordinate is 5. So this equation, dy over dx 1 over 10x, at that particular instant at point A, you can substitute the location of x inside here, you'll get 1. It means the gradient of this curve at point A is 1. Okay. So you know that dy over dx also is a tangent, right? You draw a rectangular, triangular, and you find the tangent of the curve. All right, tangent of the curve. You can also use tangent theta. Okay, now this one fall under trigonometry chapter in your mathematics. When you find the curvature of the curve, the radian on the curve, you use dy dx. And at that particular point, curvature or gradient of that point also can transfer in the trigonometry equation where you use tangent theta. Okay. So tangent theta equal 1, where you get 1 is from dy dx, because dy over dx equal to tan theta. Okay, you find the changes of y and x over here. So you can recycle the 1 inside here, you can find your theta. Right, use your calculator, find the inverse of this tangent. So at what value you get 1? This is a very simple question. At what value your tangent get 1? The answer is 45. Okay. Okay. So how tangent theta equal to 1? Theta tangent inverse 1, how you can get 45? This one the calculator will tell you, and if you need explanation on trigonometry, go back to the trigonometry mathematics textbook. There's a chapter explaining how to get, when you talk about sine curve, cos curve, tangent curve, right, in your max 1. Okay, and then 45. Up to this stage, any of you have question? How to get 45 degree? How to get dy dx? Everyone good, eh? Stop me if anything seems not very clear to you. And there's a purpose why we find dy dx in this stage, because later we need to find the radius of the curvature. Right. Now velocity va equal to this one, and this is the angle of your velocity. Right? So your velocity is a vector. Vector have magnitude and angle. So from today onwards, if this kind of question, collinear question come out, there are 2 marks for your answer. If we ask about velocity, velocity always gives us the answer, magnitude, and direction. This is how you answer this kind of question. You have to give us the magnitude and the direction. You can draw with this symbol. It's 45 degree going this direction. All right? You can see from here, right? It's going 45 degree going down. This one give you 2 marks. 1 mark for this one, 1 mark for this one. Okay, so from today onwards, when you answer velocity question or acceleration question, they will be, we're expecting you give us the direction and also the magnitude. All right. Okay. Next, we move to the next one, acceleration. Okay, acceleration. So how do you find acceleration? There's a slides about acceleration that we mentioned in our previous class. This is the slides that we're talking about. Acceleration equal to all these equations. If you want acceleration also a vector, vector have magnitude, you use this equation to find tangent square plus normal square. What is your tangent? What is your normal? Refer back to this equation. Your tangent component is v dot. Your an component is v squared divided by rho, which is the radius. That's why we will need the radius equation. Okay? So this is just a flashback, the information that we need to use to answer the tutorial question. So in this case, we are using this equation to solve. So I put the equation over here. Acceleration equal tangent component plus normal component. Okay, acceleration consists of 2 components, tangent component, normal component. So on your sketching or on your diagram, you already have the tangent axis and normal axis. I believe you can sketch on your diagram where is the normal arrow or a normal component, sorry, tangent component and normal component. So this one tangent, you just draw an arrow there. Tangent, oh sorry for, yeah. Tangent component is along the tangent axis, and its positive value is because it's going to the t direction. And why I can write at equal to 2 meter per second, the question already gives you. In the question, it says this skitter has a speed of 6 meter per second, this is velocity, and increasing at 2 meter over second square. This information is the tangent acceleration. Right? If you put a skitter over here, you're able to see why this one is 80 and not normal direction. If you put this 2 meter per second in the normal direction, it means your skitter is floating into the air, which is not logic. Right? So your skitter is going along this path in the tangent direction. So in the exam, don't draw something very funny, right? Don't draw something that on the paper already not logic, right? So don't put the statement like this one. 2 meter per second, don't do in the normal direction. If you draw arrow in the normal, means your skitter is floating into the air or shooting towards the air. So it's not logic in that way. So your AT equal to same direction on the tangent direction in the 2 meter per second. So basically, you already have the value for your tangent, right? This one is a tangent magnitude, right? Tangent magnitude and direction. This is the magnitude of your acceleration in tangent direction. This one equal to this one. And your normal direction you label as A sub n. What is your A sub n? We did this one. A sub n, this is a magnitude, this is the direction. Un is a direction in n direction. So you need to find what is this. V squared divided by rho. So you have all the equation you need. And later, once you find what is your AT, what is your AN, on your diagram, you should be able to find the resultant of your acceleration. Right? I use a rectangular vector method. I combine the two arrow here, which means sorry, let me orientate my finger. Okay. So it means I pull this arrow to this side, and resultant is from the starting point to the end point. After your vector, after you combine two vector, your resultant is from the starting point to the end point. So this is where you get your resultant vector. Okay. So the mathematics later I will show you. Try to understand how you relate acceleration formula to your schematic diagram. First, ask yourself, do you know how to draw the arrow or not? For tangent component, do you know how to draw the arrow for your acceleration magnitude or not? Which means AT arrow, AN arrow. And then from here, once you have your AT and AN, normally the next steps after you find AT and AN, which is the tangent and normal direction, you can find the resultant of your acceleration. Okay? So after this arrow, after you draw this one, is more mathematics, is more in the solution using your vector understanding and also the second order or first order of your differentiation. Okay, I continue showing you the steps, and also you know that there is an angle. All right, so acceleration have a magnitude and also angle. Angle of acceleration is over here. Okay, it's over here. This is information that you will help you to solve. Always remember your A is X and Y coordinate. X is 10, Y is 3. It will help you to find the missing parameter in your formula. So, okay, I put it over here. To find the radius, you need, this one you already done. You need to do one more time, the differentiation from here, right? Y equal to something, dy dx equal to this one. To get second order derivative, you differentiate this one more time, you get 1 over 10. Recall the radius equation. You have the dy dx, you have a d square y over dx square. The rest is just pressing calculator, and always double check your answer in a test or exam. Yeah, I've seen student he substitute the correct one in the answer, but suddenly the final answer seems very weird, and a student do not go and check. It's such a waste. Okay, so I do the detailed calculation for you. After these slides onwards, I will not show you the detail of calculation. I will treat as your homework, and you substitute. I'll give you the final answer for that one. All right. So in this case, you substitute dy dx with this one. You substitute d square y over dx square with this one. The rest, simple calculation. You arrive at 28.28 meter. In the exam, this kind of answer, I give you 2 marks for final answer. If you accidentally forget to put in a meter, we will discount 50%, meaning you only score 1 point for the radius. I repeat, in the exam, always put in your unit in your answer. I take this as an example. If the answer is 28.28 meter, you forget to put meter in the answer, you only score 1 point. If the full mark is 2 points, you only score 1 point. 50% from the answer. Okay. Any questions so far? On the slides, anything that looks doesn't make sense to you?
So far, no, sir.
Good, eh? Right.
Okay, sir, so far.
Right. Excellent. So I pull the question to one side. I just want to clean my canvas here. Right, you have the row. The next one, just to calculate your equation for acceleration. So this one also will give you some marks in the test. So always repeat the equation, then substitute. Okay. And then substitute the answer into A equal to 2ut plus 1.273 un, and the unit meter over second square. Always give your answer in this form. Okay. Now for collinear motion, you have always remind yourself you have a tangent direction and normal direction. We are expecting something of this in your answer for acceleration component. All right. And decimal place, when it comes to degree level, minimum 2, maximum 3 decimal place. Okay. Minimum 2 decimal place, maximum 3 decimal place in your answer. Okay. Stop me, if you anything that doesn't make sense to you, again, stop me. All right, we move on. So we can go back to the drawing board here, or in your sketching there, update the information, because here your AN from your calculation is 1.273 over here. Make sense? So you have A tangent, 2 meter per second. Sorry, there's a typo error here. It should be meter over second square. a typo error, take note, it should be 2 meter over second square, and it's not, this one is typo error. So, so AN equal to 1.273. Any one of you don't understand why suddenly I can write AN equal to 1.273? Any of you don't understand why suddenly in your sketching, in your sketch there, you can write AN equal to 1.273?
Yeah, I don't, sir.
Okay. Can you relate this equation to your answer over here?
Yeah, I can, sir.
All right. Okay, so what is the 2 meaning to you? 2 is what, the component?
The point V.
No, okay. Let me rephrase my question. Your acceleration consists of what axis? You have 2 axes to refer to, right? When you come
Correct.
linear. So what are the axes? What is the T?
N and T.
Yeah, what is the T mean to you?
Tangent.
Tangent. N is normal, right? So you have tangent component and normal component here. So you back to the calculation. The 2 ut, 2 is the magnitude of your tangent acceleration. Ut in mean direction, because it's a vector. Vector have magnitude and direction. You compare side by side this equation and this one. What is this component? Is the magnitude of your acceleration in what axis? N axis. What do you get for your N axis component or magnitude? 1.273, correct?
Correct, sir. Okay.
You back to the diagram. This is magnitude in tangent direction given in the question 2. Of course, again, there's a typo error in my slides here. It should be meter over second square. And from our calculation, we know that the normal magnitude of our acceleration is 1.273. That's why we can import this equation or this answer into our diagram here. That's why our A is 1.273.
Okay, sir. Understood.
Right? Yeah. So since you have your AT and AN, are you able to find A, or resultant? All right. So just recall back the vector chapter. You just find the square root of your 2 vector here, the tangent and normal. It doesn't matter you flip the sequence, you still get the same answer. The important part is you square this one, add together, square root, you get the answer. Right, this is how you get the A magnitude or resultant magnitude. Okay, 2.73 meter over second square. Right, now how do we give you marks in a test or exam? If you write the correct general equation, I will give you 1 mark here. Without starting to answer, if you give me the correct general equation in your answer, I will give you 1 mark, free mark for this one. Obviously, Dr. Ang, if I forget to write general equation, can I still get mark? I will still give you mark provided your answer is correct. Okay, provided your substitution is correct, I will give you marks for this one. But it is good, always good practice to write the general equation in your answer. Diagram itself consists maybe 4 to 5 marks. Each arrow 1 mark. Okay, each arrow 1 mark, and the axis also there are some marks there. Roughly, normally will be 4 to 5 marks for free body diagram. And all the small marking here, maybe there were some marks. Okay, so this is just a life jacket, just in case you substituting the wrong answer or you press the wrong button in your calculator, somehow the final result is not correct. All this small marking here, I will still can help you to give you some marks. Okay, not full, but still some mark for you. I will help you to score some marks if you leave your small calculation on your answer. Right? So here, I think you should be able to relate to your vector chapter to find the resultant. After you find the magnitude, you know that vector have magnitude and direction. How to find direction of this theta or pi, theta here? You see, are you seeing the triangular? This is a
Yes, sir.
normal triangular. So use your, it depends on how good you are. Some people, you are good in sine. Some people, you're good in cos. Some people, you're good in tangent. So use any relationship that you feel comfortable. By this case, a very obvious one is the tangent, because you have the opposite and you have the opposite and the side. So actually it's a tangent relationship. Okay, so I put over here. So tangent theta equal to opposite divided by side. You look at here, you assume this one as your eyes, or you stand over here. How you get tangent? Your eyes opposite and the side over here. So what is the magnitude of your opposite? Is actually this one. So you can transfer this one. Sorry, okay. You can transfer this component up there. You get a triangular. So you can use trigonometry. 2 divided by 1.273. Use your calculator. Find the inverse. You get 57.5 degree. Pull this one direction back to the answer, because for this chapter, for engineering dynamics, when you talk about acceleration or velocity, they are vector. So answer your question in magnitude and direction. You find the angle already. How do you find 12.5? Are you able to relate? Because I'm relating to the horizontal. I know that my angle over here is 57.5 degree. I know that this is my horizontal axis. All right. So here to here, okay, what is this line? This is your tangent axis. Here to here, 45. Your tangent to normal is always 90 degree, correct? Your tangent and normal axis always 90 degree. So 90 degree plus 45 plus this angle, you get a total angle from horizontal axis from here to here. And how do you find the balance that you calculate from horizontal? Basically, you take 45 degree, 90 degree, 57.5 minus 180 degree. The balance will be the direction of your acceleration. You'll get 12.5 degree pointing downwards from the horizontal. That's why I draw horizontal line and an arrow pointing down 12.5 degree. Does it make sense to you? Does it make sense to you? Maybe I give you 10 seconds just to look at this equation. Look at this diagram, 45, 90 degree, and the angle that you just found, 57.5 here. Right. Then to find the angle of your acceleration, you minus 180. 0. Okay. Any one of you need me to explain?
So can you explain it again, sir?
Okay. You don't understand how to get 2.5 degrees, is it?
Yes, sir.
Okay. Now, before we arrive at 1205, do you understand what is the angle of this one or not?
Oh, yes, sir.
If you combine the angle from here to here, or here to here, basically this diagram, because we do not draw it according to size, that's why you don't see this relationship. But based on this schematic diagram, you know that from horizontal line the horizontal reference line, you measure angle from here to the arrow, correct? Correct?
Yes, sir.
Yeah. So what is the total angle from this line to this arrow? How do you find the total angle? 45 plus 90 degree. Do you understand why 90 degree? Do you understand why here is 90 degree?
Yes, sir.
So 45 plus 90 plus the angle that you just find, which is 57.5. So here, plus 90 plus 57.5, you have a total angle from the horizontal. If you add all the angle together, it will be more than 180. Here, rotate to this arrow, you'll get more than 180 degree. The balance we measure from horizontal will be 12.5. Meaning, here, you rotate up to here is 192.5. Here to here is 192.5. What is the direction from horizontal? What is the direction from horizontal? 195.5 minus 180, you get 12.5. Do you see that question? This answer?
Yes, sir. Understand, sir.
Yeah. Anyone you still missing? You still blur how to find 12.5? Okay. You find the magnitude and direction already? Okay. Now it's about 10. Maybe we go for one more example. Right? Let's look at one example, 11. Example 11. Ignore this one. I forget to put this one in the transition. All right. Let's look at example 11, and you can go to your tutorial. Actually, you have the overall diagram. So if you read through, race car C travel around the horizontal circular track. All right. So there's a car travel in this circle with a radius of 300 meter from the center of the circle track, 300 meter with the R, and of course, there's an equation to find the R. If the car increases its speed at a constant rate of 1.5 meter over second square, by looking at this unit, you know that this is acceleration. Starting from rest. So what is your velocity from starting point? What is your velocity from your starting point? Let me ask a question. Nagesh Warren, are you there? Calling
Yes, sir.
Nagesh Warren. From this statement, starting from rest, what is your velocity starting point? Equal to what? Again, repeat your answer. I cannot hear you clearly. Starting from rest, what do you understand about this
0,
statement?
sir.
0, correct. So you have some information over here already, meaning if you start from initial, you have your velocity equals 0, and you have acceleration of this magnitude. Determine the time needed for it to reach the acceleration of 2, meaning this is your starting acceleration, and acceleration of 2 meter over second square. What is the speed at that instant, meaning when the car reached 2 meter per second over square, right? Acceleration of 2, what is the velocity at that particular point? How we solve this one? Right? You have a car moving very fast on the circular track. So when you solve this kind of question, again, standard operating procedure will be, first, draw your coordinate system, or coordinate system. where on the object itself, you copy the question. On your schematic diagram, put in the tangent axis and also the normal axis. Right? By sketching from here in the diagram, I'm going to ask someone to help me to label the axis that I draw. Shilton, are you there? Shilton? Calling for Shilton one time. Calling for Shilton second time. If your mic have problem, fix your mic. Calling for Shilton the time. Shilton, are you there? Shilton? I can't hear you. Shilton, I'm seeing some response on your side, but there's no voice from your side. There's some noise from your side, but I cannot hear anything from you. All right, I'll move to the next person. Sivendra, are you there?
Yes, sir. Yes, sir.
All right. Sivendra, you look at the diagram over here. I want you to help me to label the tangent and normal. What is the vertical axis in this diagram?
It should be tangent, sir.
Correct. What is the axis towards the center?
Normal, sir.
Correct. So this is the first thing. So always the same when you solve a collinear question. Mark the axis first. And again, I'll give you marks for this axis. So this one, minimum marks I will give is 1 mark for T and N. So yeah, so try to pick up all these 3 marks in your answer. Okay, then I will label as my car location. I will just label as C as my location. And then I put in all the information that I get from the question. For example, I use a red arrow to represent my acceleration. My acceleration always I follow the information given in this case, 1.5 meter per second square is on the tangent axis. Okay, don't be somebody who think outside the space that you draw your acceleration pointing towards normal. If your acceleration T is pointing the wrong one, your car going somewhere else. You're going to be going very near and spiral inside the center. Okay, and then that is not the case here. Your car always stay inside the circular circle. So don't label the wrong one. You have your AT and AN. Okay, and you can find actually when you have the AT and AN component, basically is a vector diagram. I use a rectangular approach method. When I combine the AT and AN, I get the resultant. I label as A as my resultant. Okay, my next step is to solve what is my AN and AT using available equation. Okay, so coordinate system, I label with my origin, my A and T axis. And again, why is A and T axis so important? Because it will give you the positive value of your calculation. That's why you can see my T axis always follow my motion direction. I do not go against my object direction because I want to give all my answer in positive. That's why my T always follow direction of the object. All right. My normal component always pointing to the center of my curvature. Okay, normal axis always pointing to the center of your curvature. In this case, we have perfect circle. Next, we look at acceleration. Why acceleration first and not velocity first? Because information given you is acceleration, so you look at acceleration first. You have tangent component, AT equal to 1.5. Sorry, again, typo error here. I apologize. 1.5 meter over second square. Okay. Yeah, of course, if this one come out, I see in the exam, I will circle this one. I'll circle this one, and then I'll put a question mark. If this one is maybe 2 mark, I'll only give you 1 mark for the answer. Okay. Next, you just call out how to find the magnitude of A, just to stand by the equation. Again, general equation in the answer sheet will give you some points. Huh? So don't skip all these general equation. You use the correct equation, I will still give you marks. Huh? And I don't think I need to explain why AN equal to V squared over rho. So if you don't understand this one, go back to the first session video. I already explained. There's one slide that I purposely put in our lecture. Okay, so your AN equal to this component, V squared over rho. So you know that when you have a constant velocity in the tangent component, you can use the 3 Newton motion equation, V equal to something, V squared equal to something, S equal to something. In this case, you're interested to find the V, especially one of the equation, you have the information from the question starting from the rest. It means V naught is 0 over here. Okay. V equal to 0 plus 1.5 t from the location of C. This equation apply to the location of C, your starting point. So our V is in a linear equation, V equal to 1.5 t. This is the equation that we have for our velocity with a change of time. Okay. If you substitute your time over here, you manage to find the velocity at that particular time. So our next step strategy here is to solve for t. How do we find for t? Let's look back any information that we can use. You know that your AN equal to V squared divided by rho. Do we have the rho? Do we have the radius? Right. You have the radius, right? So what is your V? V is the equation. 1.5 t, substitute this one inside here. You get an equation for your AN. Okay. Again, when you study about degree courses, you might not see direct substitution anymore, right? So when you do your secondary school government exam, they will always define substitution that you can directly substitute into the answer. When you do your bachelor degree courses or program, they will not see any direct answer for your velocity and acceleration anymore. You always see some relationship that define in the equation. Okay, so have some changes in your study approach. All right, don't assume that will always give you the direct information. Okay, you need to change your study methods in the degree level. Okay, any questions so far from V equal to 1.5, we can get this one. Any question?
No, sir.
Good, eh? All right. So you have 2 equations to use now. 1.5t for velocity, and for your AN component, you have this one. Relate to this diagram again. By using this equation, You have AT, you have AN. Are you able to find the acceleration at that particular time? Can, right? It's just a substitution of equation, two equation inside the magnitude of your acceleration. This one, AT in AT component, square. This one, inside there, square and square root, you get one final equation for acceleration magnitude or resultant of your acceleration. Okay? All right. Now this is the answer we have just now. AT, this one, A and this one. Use the magnitude calculation. Square your normal, square your tangent. Or basically you find the two vector there. Substitute there. Okay, so here to here basically is just normal mathematics. You have your A, right? Your magnitude A, right? So why you can substitute A as 2? Because it gives you some question, asks you to find the time when the acceleration reached 2 meters per second, meaning this A vector here is means the change of your acceleration, right? There's a change of acceleration from 1.5 to 2. So your A over here, which means the A in this diagram, is 2. Okay? Square root, substitute these two equations inside here. As you can see, this is a normal quadratic equation, or you can say as a normal linear equation, with this inside here only have one unknown inside, t. Basically, after these steps, you can find what is your t. And what is my concern is your characteristics. Some of you are quite weak when you see a bracket square or something about square. Some of you have that weakness. So just be careful in your test or final exam. Just always double check your answer. Huh? So again, your homework to go and use your calculator and press all this. Your t, just a checkpoint for you, t equal to 13.28 seconds. Important is that you understand the strategy we solve the question. Don't chase after the numbers, because the numbers will change when you come to test or exam, or even in the real scenario. Okay? Try to understand why we use that approach. Okay? Once you find the t, you can find your acceleration component at that time, right? Or the speed at that instant. Speed is velocity. You still remember your velocity? Your velocity have one equation just now. V equal to 1.5 t, and this one we derive from the Newton motion. Newton motion equation. V equal to 1.5 t. You already find your t when it reach acceleration 2. You substitute here. The velocity will be 19.9 something. Okay, 19.9 something or 19.89 something. This is the final answer that we're looking for. V equal to 19.9 meter per second. Okay. Okay, with this we end our lecture for today. Let me stop the recording. Any